the chair of the symposium, Destroying the Cytoskeleton. Jennifer Ross joins us now. Welcome. Tell us about it.
Well, so I'm really excited about this symposium because I think there's been a lot of emphasis on the cytoskeleton and in cytoskeletal research on how you can grow the cytoskeleton, how you can form it or build it. I mean, the cytoskeleton is composed of actin and microtubules, and these things are thought to be kind of the building blocks of the cell. They help to support the structures, they help the cell move, and they help to organize the interior of the cell. And so we often think about when building a house, but we don't always think about sometimes we need to purposely destroy part of our house. I mean, you do though, right? When you're renovating a kitchen, you purposely destroy it so that you can rebuild it. And the cell does the same thing. And so this session will be talking about how we can purposely destroy parts of it, the different mechanisms that are used, whether they be enzymes that purposely sever parts of the filaments. Sometimes they're not even enzymes, they're just other proteins that can bind and help to break apart the filaments. And then sometimes they actually cause the depolymerization from the ends of the filaments so that the filaments will shrink over time. And what we don't realize is this programmed destruction is actually really important for the cell to go through different parts, such as cell division, or to develop from kind of a stem cell into the next phase, a bone cell, a nerve cell, whatever. And so it's really important to be able to destroy parts of the structural elements inside in order to recreate them.
What do you think will surprise attendees?
I think what will surprise attendees is that when we learn about how to destroy these filaments, we often will learn also about how to create these filaments. So in the destruction, we actually learn about birth. And so this kind of circle of life between the death and the birth of these filaments is intimately related in the cell and how the cell is organizing the structure inside of it. And so I think that's going to be something that's going to be surprising and fascinating. And it really shows you the cutting edge of what we're able to do in cytoskeletal research.
And what do you hope people learn?
I hope they come away with kind of a fascination, especially if it's a new student maybe who knows about the cytoskeleton but maybe hasn't doesn't know too much and is kind of new to the field, that how exciting and kind of dynamic but regulated this system is. The cell really can control where it grows certain aspects of the cytoskeleton, where it puts actin, where it puts microtubules. It can control the stiffness of these things. It can sense using the cytoskeleton and respond and change that cytoskeleton, both through destruction as well as through kind of just moving it. And so I think that really the cytoskeleton is at the base, the base of the structural elements that make a cell autonomous. I mean, and this is really kind of a fundamental aspect of being alive, is that you are autonomously able to sense your environment, do a computation, and decide how you're going to change. And then you can actively change and move and create force and work in that direction. And so I think what we're starting to see with cytoskeleton, and I'm hoping will come out in this symposium, is this idea of autonomy of this system, the ability for the system to be its own entity, sense, respond, and kind of solve problems.
All right. Thank you, Jennifer.
No problem.